these panels. First of all, these panels, they get some problems with these components that are inside. So these components, any failure in this component can lead to something not working very well, either the motor not running, a control panel screen not coming on. So we have to make sure that the circuit breakers, the contactors are in place and working properly. Most times there is some loose connections in this control panel. Then there is also dust. Dust can affect this. So also you find a situation where the cable has been used for a long time and it is reducing in resistance, and therefore the cables get burnt. As you see here, these are the control circuits, as you learned maybe in workshop 1, workshop 2. So as these motors are starting to run, they draw a lot of current, and usually there is sparks in this control panel. So you have to always monitor the spark not to exceed the normal spark that we always expect as it changes from star to delta. So these are the maintenance procedures that one can follow whenever he's doing some maintenance on a control panel. First of all, you have to turn off power. We always have a main circuit breaker here on top. Yeah, so whatever you do before starting maintenance, always ensure that power is turned off. I also do some visual inspection. I inspect the sparks. If they are beyond what I expect, or if it is an abnormal spark, then I act immediately. That could be as a result of a loose connection or overload to the motor. So there is cleaning. Cleaning is essential in maintenance, and most people overlook cleaning, but cleaning is essential in a way that if these circuit breakers, contactors, overloads, and timers, if they are not cleaned, they connect themselves. Like, they are connected by electromagnetic induction. So that if there is a lot of dust in between, you find when the contactor gets interlocked, it fails to come back. Or when the circuit breaker trips, it will fail to come back. Sometimes you may think the circuit breaker has tripped, yet it has not tripped due to dust. And also dust in these connectors, it makes it loose. So you have to always clean the panel. Make sure it is very clean. You also clean each component there. Each component here, it's like separately, like we always clean these contactors. We open them, clean the contacts. Like we schedule it maybe every after 3 weeks, but you always do it monthly. Open these contactors and clean the contacts. So we always tighten electrical connections. This is to fight against loose connection, and loose connection is a very big problem in control panels. Then we have component testing. We test each component in case of any failure. We test each component. So you may find the circuit breaker here is not working. If this circuit breaker is not working, this one, or this contactor is not working, the system will have a problem. So we need to test each component against its functionality. Then It is of great importance because it prevents downtime by ensuring that the control system functions correctly, reduces risks of electrical fires due to overheating and loose connection. So overheating, loose connection can result to overheating of a component and leads to overheating of the motor as well. As maintenance of motors, also I do maintenance of motors. Electric motor drives various mechanical processes in the plant, such as conveyors, grinders, and mixers. So a motor is a very big component in our factory. It does almost everything. So its functionality is crucial in the production. If it is working properly, it increases the production output. We produce a lot of products. So we always ought to make it work efficiently. So we normally check on the lubrication, insulation, alignment checks, vibration analysis, temperature monitoring, and cleaning. So lubrication, always make sure that the motor is running very well so that it doesn't show some overload, tripping, all such kinds. So if the motor is facing some complications in running, then it will come back to it drawing a lot of power from the circuit breakers. Hello, are you hearing me?
Yes, we can hear you.
Yes, we are hearing you.
Oh, thank you, sir. So bearings in the motors need lubrication to function smoothly. For example, lack of lubrication in a conveyor motor would cause overheating and eventually failure. Yeah, that is the main thing. If the motor is facing some complication in running, it will draw a lot of current and it overheats. So you have to make sure it is smoothly running and it is lubricated. Then insulation testing, use of the insulation tester comes to place here to ensure that the motor windings are not compromised. For instance, a drop in insulation resistance could indicate moisture that has been created in the motor winding, leading to a short circuit. So if the insulation of the motor comes down, that means there is some moisture that has been created either in the primary winding or secondary, or in the starter or rotor, that will create a short circuit in the long run. Then we always do alignment checks. For the alignment checks, we always consider that the motor is running at a required speed and it is placed where it is supposed to be. Like it is not facing complications in running something that is maybe far away from it. We always make sure that it is aligned in relation to what it is running. Then we always do vibration analysis. High levels of vibration can signal issues like misaligned shafts or worn bearings. A motor driving like big things, we always have hammer mills. For example, may it vibrate excessively due to bearing wear. So we always monitor their vibrations. If you see a motor vibrating abnormally, we always check of any problem. It could be the bearings having issues, maybe overload, like that. So always also monitor the temperature of the motor. The motor running a grain hanger may, if overloaded, so regular temperature checkup helps to prevent damage due to overheating. So overheating can create a very big problem on a motor. It can lead to a motor failure. So cleaning is essential because cleaning covers almost everything. I included cleaning. Cleaning is my routine maintenance. I always do cleaning of these motors daily so that the motor is working smoothly every day. Then proper motor maintenance prevents costly breakdowns and ensures efficient operation of the mechanical processes in the plant. So we always make sure the motor is working very well. Then I also do maintenance of generators. Generators, we have 2 generators of 400 volts. One works in the processing, another one works in the production. So they provide backup in case of when there is no power or when the power gets off or when we have unstable power. The power is always not stable here. We always have one phase off, maybe 2 phases have got some issues. So we just need to connect the generators. So these generators also have some maintenance procedures that I always check on daily or monthly or annually. So I always check on the fuel system. The fuel system, that is the fuel filter, must be replaced regularly to avoid blockages. For example, if the fuel filter in a diesel generator clogs, the engine may sputter and eventually stop. So I think last week but one, we had some problem with our fuel filter. Could start the generator, it shows that it is starting and then stops immediately. So checking the fuel system, we managed to do that to fight against it. So we always check about the batteries. The battery, always make sure that the battery voltage is working very well. It is at the required. Our generator uses a battery of 24 volts. So we always make sure it is at 24. So regular testing of the generator batteries is to ensure that it holds a charge that is enough to make the generator run. A generator that won't start during an outage due to a dead battery could make the operation not successful, like we don't run. And each day there is a set that you're supposed to produce, like a target. So any failure of these systems can lead to us not getting the required targets by the administrators. So I always check on the coolant system due to generators can overheat without adequate coolant. For instance, if the coolant level is low or there is a leakage in the system, the generator may overheat and shut down. So these coolants, they are very, very important in the generator. Then we also inspect the electrical connections, maybe some loose connections anywhere in the engine. We tighten, especially on the relays that take information to the to the display unit. If they display false information, the generator cannot go on. So always make sure that they are tightened. We also carry out the exhaust system inspection, make sure that the exhaust is working very well. We also do load testing. We make sure that the generator can run the plant and load. So to ensure that it can handle the plant's power demand. For example, testing our 400 battery generator, under load stimulates actual conditions and confirms that the system can run the plant. Always also do air filter maintenance. We replace the filters and clean them during maintenance. Then also regular generator maintenance ensures reliable backup power during outage, preventing cost disruption in production. Proper upkeep also extends the generator's lifetime and maintains fuel efficiency. So I also do maintenance of the power line, the line that supplies to our plants. Always do maintenance on it to ensure that the power is reliable, to reduce on the downtime. So the power that supplies to our plant always have some issues in terms of the phases. You find one phase is off or two phases are off, and in a situation where one phase is off, the motor can run, but it runs with some sound. You hear that sound that is not good. Or you find the motor is running but with complications, and it cannot reach its normal speed. So you know that the one phase is either off. So I do some activities regularly, weekly. I do some regular inspection on poles, transformer, and connections. So some poles, you make sure that the pole is erected very well. We always monitor the transformer that supplies to our plant. Here we check on the cooling of the transformer. We always monitor also its vibrations, like the noise. Also check on the connections in our terminal box. Any loose connection in the terminal box can lead to excessive sparks that can cause a failure or tripping of the circuit breakers. Do testing for electrical faults, insulation, degradation, and load balancing. Make sure that the loads are balanced. We trim vegetation and clear obstruction near the power line, replacing the blown fuses, circuit breakers, and tensioning the power line cables. Now there is this is the maintenance that I'm doing, clearing the vegetation below the line, and always making sure that these cables, the sag between these cables is minimized, so that there is a point where you find one phase is soon touching the other due to excess load or to excess loading in one of the phase. You find one phase is still good and another phase has some sag that is abnormal. So always do tensioning. We'll always do some tightening of the connections. Now, like here, this circuit breaker would usually trip due to the loose connection and the poor balancing of loads. So the safety considerations during maintenance is very important. You have to make sure safety is everywhere. And safety begins with the person in charge, the one operating or carrying out that operation. You have to make sure the safety is on your mind even before you start, because it starts from you, then it goes to the staff, the operators, the cleaners, everyone. So I always do log out and tag out procedures before I start any maintenance. I make sure that the power is off. I make sure that all this the terminal boxes, I check of how the line flows. I make sure at every point that needs to be turned off is turned off, and I tag. There is some tags that we put on a system showing that the system is under maintenance, so that no one could switch on as you're working. So log out and tag out procedures are very essential. You first switch off, you unlock, then you test, you make sure that the line is de-energized. Make sure that the line is de-energized, isolated before performing any maintenance. For instance, before servicing a control panel, a log out and tag out ensures that the equipment cannot be powered on accidentally. Yeah. Then there is the personal protective equipment, the PPE. So we always wear insulated gloves, safety goggles, and proper footwear when working with electrical systems to prevent accidents. The PPE is very, very essential when carrying out maintenance in relation to your safety and the safety of everyone in the plant. Also, proper tools and instruments is necessary. Use of multimeters, insulation testers. Using now, like if you use a star in testing if power is there, so that is a wrong tool. You may be electrocuted within a minute, very fast. So also we fill the risk assessment form before doing any maintenance. And doing any maintenance without a risk assessment form, it is prohibited here in our factory. You have to always get the risk assessment form and you assess any possible risks that are likely to occur and look for the solutions. What are the solutions to those risks? If they are all matching and there are no possible risks, then you proceed to the maintenance. So we do maintenance schedules. Maintenance schedule, we don't just say today we are doing this maintenance, tomorrow we shall maybe maintain the generator. Like that, there is some procedures we follow in making maintenance schedules. You cannot say every day we are going to be tightening connections to overcome loose connection. If you over tighten the connections or tightening connections, let me say on the motors, always tighten the cables in the terminal block. So if you tighten them daily, you'll end up breaking the terminals. And the plant, will not work smoothly due to your maintenance. The maintenance must not affect the plant's production. So you have to schedule maintenance depending on some factors. You either make it daily, monthly, or annually, depending on how the system will be showing up. So when we are doing maintenance schedules, we always check on the MTTR, always check on the MTTF and MTBF in relation to their impact on maintenance. MTTR, this is the mean time to repair and mean time to failure, mean time between failures. So these matrices are very crucial when doing maintenance schedules. So the MTTR, that is the mean time to repair. The average time to repair a system after failure. How long will it take to repair a failure in a motor? If the motor gets a failure, how long will you take? How long does it take to solve that failure? So this time that it takes is very essential, and since time is money. So if you spend a lot of time working on a failure, that means you're delaying production, you're delaying output. So at the end of the week, the target won't be achieved. So you have to always monitor that time it takes to repair a failure, to repair a system after failure. So a low MTTR means faster repair and less downtime. It's used for corrective maintenance planning. So if the system takes less time to repair, if it takes less time, you cannot plan to always repair it, maybe monthly or every after 2 months. It takes short time. For it can be used for corrective maintenance. So MTTF, that is the mean time to failure. The average time of a non-repairable component operates before failing. So if you buy your motor today and it takes maybe 3 days without failing, or 1 year, that is your mean time to failure. You bought it, you have never replaced it, and it is operating for 1 year. That is your mean time to failure. It helps to plan replacement and preventive maintenance. So if you buy your motor today and it takes 1 year in operating, or it takes 2 months operating, probably I will not recommend the same motor to be bought next time. So the mean time to failure helps you in setting the preventive maintenance and also recommending on the best suppliers, manufacturers, you know, which company gives the best material, the best product. That depends on the MTTF. Nowadays, Tronic is taking away all other products depending on its MTTF. Its mean time to failure is too high depending in relation to other products. So I always recommend them to buy products with high MTTF. For example, if the MTTF is 10,000 hours, maintenance is scheduled before this point. So we can schedule our maintenance maybe below these hours, to reduce on the downtime So we also have the MTBF also as a matrix. That is the mean time between failures. Mean time between failures, that is the average time between failures in a repairable system. You have repaired the system on Monday. You have also repaired also the same system maybe next Monday on another Monday. So it is taking only 1 week. Every week you repair. So the time between the first repair and the second repair, that is the mean time between failure. It has failed for the first time, it has failed for the second time. What is the time it has taken for you to again repair it? So that time, we always have some records. We check on each system, each product with each time. So we use that time in scheduling preventive maintenance. For example, if the MTBF of a component or a motor is 5,000 hours, maintenance is scheduled at 4,000 hours to reduce on the downtime. So availability, that is the proportion of time equipment is in operation. How long has your motor been operating without any failure? It is very important because that is the time that determines production. That is the time that they use in the office to estimate the production, maybe in the next month, production in the next week. They use availability of the equipments of the machines. So also have the availability of each component, the motor, the power lines, the control panels, the generator, for how long will it be available. So we have also the failure rate. That is the time it has been in failure. The time it takes to that it has been not working. You'll be having the total time, you know your availability. So if you get your total time and you remove the availability, that means you'll be having your failure rate. That is the time it has not been working. So it can also be expressed as a failure per unit time. So these matrices influence maintenance schedules, as in preventive maintenance, corrective maintenance, predictive maintenance. We always use MTBF or MTTF to avoid failures. For corrective maintenance, you always use the MTTR to reduce downtime after failure. You make sure that if it's like it takes less time to repair, takes less time, that means you can do it within a short period of time. They be in the system and they know that this component we can do it within a short period of time and the plant continues working. So that is corrective maintenance. Predictive maintenance, that is condition-based maintenance to optimize timing. So maintenance scheduling, for example, if a machine with MTBF of 1,000 hours and it has MTTR of 5 hours, preventive maintenance should be scheduled at maybe 800 hours to avoid failure. And if failure occurs, repair time is planned to take 5 hours, like that. Benefits of regular maintenance: there is improved reliability, enhanced safety, cost saving, optimized production. So in conclusion, regular maintenance of control panels, motors, generators, and the power line is critical to the plant safety, efficiency, and cost effectiveness. Prioritizing routine maintenance, testing, and preventive maintenance will help the plant to achieve long-term operational excellence and avoid unnecessary breakdowns.